Tap to Motion Blocks, Advanced IO-based Joystick. We can use events to recognize the occurrence of an input that commences motion for a manual joystick. We can wait until that condition is no longer true and stop. So that's one way to do a simple joystick. It's also necessary to turn the motor on before we use it and establish a nominal speed, acceleration, and decel. One of the challenges with the joysticks is you want both fine tuning capability, small adjustments at low speeds, as well as the ability to traverse a large area quickly. One of the ways that we can do this with simple I/O is to have a joystick which doesn't just jog the motor, but does a number of things that helps us achieve those goals. One of the things that we can do is use a method that first, when you touch the joystick, bumps the motor at a relatively high speed, not that high a speed, maybe that high a speed. So when we first touch the input, we set the speed high, and we move by a very short distance, something on the resolution of the machine's resolution or the resolution of interest for the process. A small little displacement that might be the amount that you might want to attune or adjust a position. And then while that input remains active, we want to continue moving by jogging but rather than just jogging at a slow speed, we'd like to be able to have that speed increase. So let's create a variable called joystick speed. We will initially assign joystick speed to be a nominal speed, perhaps 2000. Perhaps 10 milliseconds, increase the speed. So we'll change the joystick speed by 1. And when we are no longer holding down that input, we'll stop. So let's review what this does. Initially we press the input, the on-event handler recognizes the input, and we do a short little bump as a kind of discrete positioning adjustment. If we continue holding beyond just a nominal amount of time, that might need to be more like 100 milliseconds, then we start jogging at 2000, and as time goes by, 100 times a second, that speed will be adjusted. So in the course of that 1 second, the motor will start ramping up in speed, going faster and faster. So as we hold down that button, the axis will increase in speed. There are some clock adjustments, digital clocks, that show this behavior. You press the button, you get 1 increment in time, you continue holding, and then the number starts more rapidly and rapidly changing. We might want to put a speed limit on this. If we have a long machine, this speed could keep on escalating, possibly to an unsafe speed. So we'll put a check in here. We'll change the speed by 1, and we'll ask the question, if the speed is greater than a certain amount that we want to consider our maximum speed, let's say that would be 10,000, then we'll set the speed back to that maximum so that we don't go excessively fast. 10,000. So that's the complete advanced joystick for one direction. Let's duplicate that and consider the other direction. Here we're going to be bumping by minus. Set speed is an absolute value, 50,000 counts per second in whatever direction it's going. Jogging is a signed value. We can jog positive or jog negative. We're considering input 2 now. We jog now at a negative speed, and here we change speed by minus 1, so as to decrement the speed. Now we have to change our condition here, that if the jog speed is less than minus 10,000, then we set the speed to be minus 10,000. So that handles all the considerations for the other direction. So this type of joystick is much more versatile and usable, allowing us to both do fine-tuning as well as high-speed traverses.